25% of the iron is lost by corrosion every year, so there should be some methods to prevent the corrosion of the iron. One of the simplest method is to place a protective coating of the paint, oil or varnish on the surface of the iron to prevent its direct contact with the air or moisture, and this can reduce the chances of the corrosion of the iron. And other method is to place the coating of some other metal on the iron sheets, and this will also minimize the contact of iron with air or moisture, and it will also help in preventing the corrosion of the iron. And the first method is to place the coating of the tin on iron, which is called as the tin plating or coating iron with tin, or it is called as the cathode coating. For this, we will dip a clean sheet of the iron in the molten tin that gets deposited on the surface of the iron, and to make the protective coating firm. Now this piece of the iron that will be placed between the air rollers, and when these rollers will roll on the piece of the iron, then the coating of the tin, it will be firmly bonded to the iron. In this way, a protective coating of the tin is placed on iron, and this protective coating will prevent the corrosion of the iron. But what happens if this protective coating is damaged? My dear students, if the protective coating is damaged, then a galvanic cell will be established between iron and tin. Suppose that this is the piece of iron on which tin was coated to prevent its corrosion, and now this coating is damaged. My dear students, the tin and iron both are present in a moist environment which is rich in H positive ions, OH negative ions, and HCO3 minus ions. These H positive ion and OH negative ions are produced by the ionization of the moisture or water in the air, and this carbonic acid is produced by the ionization of the carbonic acid, which is naturally present in the air due to the reaction of moisture and CO2 in the atmosphere. Now, my dear students, when this galvanic cell will establish, obviously there will be a redox process that will start, and in this redox process, the iron will be oxidized to Fe plus 3, and now this tri-positive ion will combine with OH negative ions present in the atmosphere, and it will be changed to ferric hydroxide, and this ferric hydroxide gets dissolved. In this way, the chemical decay of this iron starts and the iron gets corroded. While as far as the tin is concerned, these three electrons, they move from iron to the tin, and on the surface of the tin, the hydrogen ions, they get reduced, and hydrogen gas is produced. In this way, the iron is oxidized, and the one which is oxidized, it acts as anode, while the tin, on the tin, this reduction reaction takes place, so this tin will act as cathode. The metal which acts as anode, it gets oxidized and it is corroded, while the metal on which just reduction reaction is taking place, it is not involved in any reaction itself, this metal is not corroded. So, if there is coating of tin on the iron and that is intact, then the iron will not get corroded. But once the coating of the tin is damaged from the surface of the iron, then the corrosion process will become very fast due to the development of this galvanic cell between iron and tin. If there is a piece of iron on which there is no coating, this piece of iron will get corroded very slowly. But if there is a piece of iron on which there was tin coated, but the coating is damaged, the corrosion of this piece, that will be very faster. So keep in mind that this is very useful, but it is useful till the coating is not damaged. Once the coating is damaged, then the corrosion of iron, that will become very, very, very fast. Now, why only iron gets corroded and tin is not corroded? Because in the electrochemical series, which is the metal reactivity series, iron is present relatively in upper portion as compared to the position of the tin, and the metal which is above or at the top position in the electrochemical series as compared to the other metal, it has high standard oxidation potential, very low standard reduction potential, and the metal which has high oxidation potential and low reduction potential, that is highly reactive. In this case, in electrochemical series, iron is above tin. Tin is the metal which will be having very low value of standard oxidation potential, high value of standard reduction potential, and it is very stable, less reactive as compared to iron. So that is why the metal which has high oxidation potential, low reduction potential, which is the reactive metal, always acts as anode in the galvanic cell. It gets oxidized, and when it gets oxidized, it gets corroded. While the metal which has low oxidation potential, high reduction potential, which is relatively stable, it will always act as cathode. And when it will always act as cathode, it will not get oxidized, and because it is not getting oxidized, it will not be corroded. So this was about the tin plating. Now let us see another coating which is a very modern method of the prevention of corrosion of iron, and that is the galvanizing or zinc coating or anode coating. For this, you will place a piece of the iron in molten zinc chloride, and then, my dear student, this piece of the iron is heated to make this protective layer firm on the iron. And till the coating of the zinc on the iron remains intact, the iron cannot get corroded. But what happens if this coating gets damaged? Now, my dear students, suppose this is piece of iron on which zinc was coated, and now this coating is damaged at this spot. Again, a galvanic cell will form between iron and zinc, and again these two metals will be in the environment rich in H positive ions, OH negative ions, and HCO3 minus ion. Now, which metal will get corroded? Zinc or iron? Again, we will have to take help from electrochemical series. In electrochemical series, zinc is above iron. It means that zinc is the metal which has low standard reduction potential, high standard oxidation potential, and it has high reactivity. While iron being below in the electrochemical series, it will be the metal with high standard reduction potential, low standard oxidation potential, and it will be stable or less reactive as compared to the zinc. So when the galvanic cell will establish the metal which is more reactive, it will act as anode and it will get corroded, and the metal which is less reactive, it will act as a cathode and it will not get corroded. The reaction that takes place in this galvanic cell is a redox reaction, in which, my dear students, the zinc gets oxidized and the iron gets reduced. So zinc will change from 0 to +2, it will be oxidized, and iron from +2 to 0, it will be reduced. And the metal which gets oxidized, it will act as anode, and because corrosion is an oxidation process, so that metal will be corroded. And the metal which acts as cathode, which is being reduced, it will remain intact. So if the coating of zinc gets damaged, even then iron will not get corroded, rather zinc itself will be corroded and protecting the iron. Because zinc itself gets corroded but it protects the iron, so this is called as the sacrificial corrosion. zinc sacrifices for iron, and this zinc coating or galvanizing, that is the process which is a very modern technique, and this is the process which is used to place the coating on the iron pipes used in the sewerage system, because those iron pipes are continuously exposed to water. So even if the coating of the zinc gets damaged, the iron remains intact, and those pipes, they have a very long life. And my dear students, why it is called as anode coating? Because the metal which is coated on iron acts as anode in the galvanic cell. And why it is called as cathode coating? Because the metal which is coated on iron, that acts as cathode in the galvanic cell. So that is the reason why it is called as anode coating and why it is called as cathode coating. Now you can easily judge that this technique is much beneficial as compared to the tin coating, because if the coating of the tin damages, the corrosion of the iron becomes even faster. But if the coating of the zinc gets damaged, iron remains protected. Zinc itself is corroded, and that is a big sacrifice for iron, and it is called as the sacrificial corrosion. So these were two modern techniques to protect the iron from being corroded. I hope so that this lecture will be quite understandable for you people. If you feel any problem, don't hesitate to ask in the comment section. I will definitely be there to help you out. Till then, take care.